Good day everybody, good day. Welcome back to the channel. Happy New Year, guys. So now we are back again. So today we're doing organic chemistry, an interesting topic. So now organic chemistry, it is the chemistry of carbon compounds in the living and non-living systems. So we'll be just checking more on these things, and then at the same time what we have to know it is that organic molecules are molecules containing what carbon atoms. While least I'm still there, let's talk about chemical bonding. So now you know from your lower grades that the carbon, which is like this C carbon, it is always surrounded by exactly 4 bonds, which is here, 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 and here. So now it is what 4 bonds. Okay, so now that is how it is, because today I just want us to do an introduction of this topic before you go deeper. And then at the same time, oxygen, which is O, it is always surrounded by exactly 2 bonds. Okay, let's continue again. So this one is what 2 bonds. The next one, it is what hydrogen. Hydrogen, it is always attached to exactly 1 point. The last one, it is now a halogen. A halogen, it is attached to exactly 1 bond. So in chemistry, a halogen, it is denoted by the letter X. Is it fine, guys? So now that's how it is. So now, without wasting time, let's continue now to the thing. The next thing that you'll have to know it is that we have what you call a homologous series. So we have 9 different things on the homologous series that you're going to be dealing with. It is the classification of organic molecules according to the homologous series. So it is 9 of them. So now the first one, it is what alkanes. So now I'll be doing separate videos on these things. Alkanes, alkenes, and then now this one, it is what alkynes. And what you have to know it is that these ones are what are referred to as hydrocarbons. Okay, hydrocarbons are molecules that contain like between their things there is only hydrogen and carbon only. So these 3 are referred to as what hydrocarbons. You'll know more about these things soon. That's that today we are doing what introduction. Number 4, we have what to call haloalkanes. Okay, and then number 5, we have what alcohols. These are the things that we'll be dealing with, alcohols. And then number 6, we have aldehydes. And then number 7, what do we have there? Number 7, we have what we call ketones. And then number 8, what we have carboxylic acids. And then number 9, the last one, it is what esters. These are the things that we'll be dealing with. Okay, these are the things that we'll be dealing with on the organic chemistry thing. So now let's continue now and do what you call stem name. So let me take another paper. So now on this thing of stem name, the stem or the root name of different hydrocarbon and members of other homologous series is determined by the number of carbon atoms in the chain. Okay, so now this is how we do it. Like we are gonna be calling, or like the way we write them in our thing, based on the what you call the root or the stem name, okay, of different hydrocarbon atoms, hydrocarbons and members of other homologous series, because it is determined by the number of carbon atom. So now let's start. Now I will say what the number of carbon atoms. This one is number of carbon atoms. Okay, now 1, 2, so let me end there. So now in this side I'll be having number of carbon atoms, and then this side I'll be writing my stem name. So stem name, remember what I just said, the what you call the root name of different hydrocarbons and members of other homologous series is determined by the by the number of carbon atoms. on the chain. So when you have one carbon atom, it is referred to as what? Meth. Okay, it is meth. And then when you have two carbon atom, it is what? Eth. You see? Then if we have three carbon atoms, it is what? Eth. Sorry, I'm repeating the same thing. Prop. When you have three carbon atom. And then number 4, when you have 4 carbon atom, we refer it as what? Buth. Okay. And then now number 5, when you have 5 carbon atom, we refer it to as what? Pent. Okay. And then now number 6, when you have 6 carbon atom, it is what? Hex. And then 7 carbon atoms, hept. 8 carbon atoms, oct. In this chemistry, there's non and oct, but we end at 8 carbon atoms. So now this is what you have to know, guys. These are the only stem names, ne? But now there's something that you'll have to know. Each and every hydrocarbon and other members of the homologous series, they have their own suffix, which means they have their own ending. Okay, but you'll know more as I'm gonna be uploading more videos about each and every homologous series or hydrocarbon. Because for example, let me just do for example, e.g. alkane. This one now, its suffix, it is what? Ane. A-N-E. Yeah, one. So now, as you can see, it is A-N-E. We can even refer to other things here. As you can see, the suffix for alkane, it is what? A-N-E. And then the suffix for alkene, it is E-N-E. The suffix for alkyne, it is Y-N-E. So now let's take this one, alkane only, as an example. If I have one carbon atom and it's an alkane, it will be what? Methane. You see, you simply take your stem name and add this suffix, which is what? E-N-E. Then it's methane, which means you have one carbon atom. When it's eth, ethane. Prop, propane. But, butane. Pent, pentane, etc. Yeah, one. When it is alkene, meth, methane, ethene, propene, butane, etc. But you'll know more as you're going deeper. Now we are just doing what you call the introduction there. Do you understand me? So now after that, now you'll have to check something there. Now since you know your stem names, now I want to know to show you now the different things, now other things about the structures and stuff. So let me take another paper. Now guys, since this one is an introductory video, so now I'm gonna use alkane as my example throughout. So now let's say I have alkane. What is the general formula for alkane? It is CnH2n plus 2. Okay, can you see how I'm writing this N2N? It is now what subscript there, down there. So now since I have this, alkane have carbons like this. Okay, so now check something there. We have what you call molecular formula. It's a chemical formula that indicates the element and numbers of each atom in a molecule. So for example, let's say I have how many carbon atoms? I have let me put 2 carbon atoms there. So now let's go. Since I have 2 carbon atoms, whenever you have 2 carbon atoms, this is how you're gonna do it. Since this one is the general formula, CnH2n blah blah, whenever this n, you're gonna put what? 2. So it's gonna be C2. This 2, it is telling you that you have how many carbon atom? 2. Then H2, then times 2 plus 2, which means I have C2, H2 times 2, 4, plus 2, 6. So this is how it is. It basically means I have 2 carbon atoms and 6 hydrogens. We can even count 1, 2 carbon atoms. Then the hydrogen atoms always belong here. They are always bonded to this thing, carbon. Remember, I told you that what you call the when I was starting, I told you that the hydrogen, it is always attached to one bond. So that is it. Let's count 1, 2, 3, 4, 5, 6, which is how many? 6 hydrogens. Can you see it? So now that is what I was talking about when I was saying what molecular formula. So now let's go to the structural formula. Whenever on a question paper they are talking about the structural formula, this is what they are talking about. This is the structural formula of the what C2H6. Or now, since you know the stem name and the ending, the suffix of each thing, now this one you can call it what ethane, because this is how many carbon atoms? 1, 2, F. And then what is the suffix of alkane? ANE. You see, so this one is referred as what ethane. Can you see it? So now let's continue. This is the structural formula. A structural formula of a compound, it shows which carbon atoms are attached to which within the molecule, and atoms are represented by their chemical symbols, and lines are used to represent all the bonds that hold what you call the atoms together. Now let's go to another thing, which is what you call a condensed structural formula. So now, as you can see, this notation, it shows the way in which carbon are bonded together in a molecule, but this does not show what the bond lines. So in a condensed structural formula, you don't show what you call this, what you call the bond lines. Okay, so now let me show you an example. Now on this thing, you do not show what you call the bond lines. So now I'm gonna show you a condensed what you call structural formula of ethane. How many carbon atoms do I have on this one? It is simply C. But on this carbon, on the first carbon atom, how many hydrogens do I have? I have 3. So it is gonna be CH3. Now let's check the second one. It is C, and then what is how many carbon atoms? How many hydrogens? Sorry, 3. So this is the condensed structural formula of what? Of this ethane there, as you can see. So there are no bond lines, as I said. And then at the same time, I told you that hydrocarbons are organic molecules that consist of hydrogen and carbon only. Okay, because now as you can see, this one is a what? A hydrocarbon, because there's what? Hydrogen and carbon only. Those are the things that you have to know there. Okay, so now guys, one last thing that you have to know, they are what you call saturated compounds. So saturated compounds are compounds in which there are no multiple bonds between C atoms in their carbon chains. So now this one is whereby it is something like this. There are no multiple bonds. There are molecules whereby you'll find double bond lines on their structural formulas, but you'll understand as time is going. So now this is the introduction that I have for you on organic chemistry. Thank you very much, guys. Keep on checking my videos. I'm gonna be uploading alkane, each and everything on a separate video, because there are many things under that thing, so that you may be able to understand it quick and simple. Thank you very much, guys. Don't forget to subscribe.